Hello, all. I'm going to present on non-SQL databases. Uh, my topic is on non-SQL databases, so I'm going to present on non-SQL database. So, non-SQL database. What is non-SQL database? Non-SQL databases offer flexible storage and retrieval mechanisms deviating from strict consistency modules of relational databases. They enable horizontal scaling and higher availability, crucial for handling sudden spikes in user activity. By distributing workloads across each each clusters of smaller cost-effective machines, NoSQL databases ensures against failures, data persistence, and replication techniques used like shading further enhance fault tolerance. Additionally, many NoSQL solutions are open source and cloud compatible, reducing infrastructure cost and complexity. And the NoSQL features allow sometimes not a well-defined schema and allow semi-structured data still need to provide ways of query efficiency, need to express specific type of queries very easily. And the flavors of the non-SQL database like key value store, and there are four main types. It's a key value stores, document databases, column family stores, and graph databases. And here we talk more about document databases like MongoDB. Document databases exemplified by MongoDB excel in organizing diverse data types. MongoDB stores information. MongoDB stores the information as a separate documents akin to files and folders, facilitating easy management of complex data structures. Its ability to nest nest documents simplifies representing relationships between data elements. MongoDB scalability ensures smooth performance as data volume increases, making it ideal for rapidly growing applications. In essence, MongoDB functions as a highly adaptable and effective representative for a wide range of data, offering both simplicity and robustness in handling large datasets. And it also have the examples for including document datasets like MongoDB, ConchDB, Terrasto. A store key value, however, the value is a documented. It has been semi-structured model and XML, modern often JSON or JSON binary counterpart. The value can be examined and used by DBMS, unlike in key or data stores. Query can be based on the key. More often, they are based on contents of the document. Here again, that suppose shading application, reapplication, the shading can be based on values with the documented. The structure spectrum, which has three types: structured, semi-structured, and unstructured. The structured has a relational database and formatted messages, and unstructured has plain text media, and semi-structured has a documented XML and tagged or tagged text or media. The MongoDB examples for document databases are like the collection of data store set of documents, collection like table and document like record. But each document can have a different data set of attributes even in the some collection and some semi-structured schema. Only requirement is like document should have an underscore ID field. And the example for MongoDB, like the mentioned one, and the MongoDB examples for key features like JSON style documents actually uses JSON's binary format, and the replication for high availability, auto trading for scalability. Document based queries can create an index on any attribute for faster needs. And the MongoDB terminology is like relational term to MongoDB equivalent. It's like database to database and table to collection, row to document, attributes to fields, and primary key to the underscore ID field, which is the key associated with the document. And the JSON is an alternative data model for semi-structured data. JavaScript object notation built on two keys like an object which is sequence of name or valuable pair. The value can be an automatic value string, number, object, true, false, null, object or array. The ID field like it underscore the underscore ID field is a documented must have an because it has an underscore. Each of the MongoDB documented must have an underscore ID field. Its values must be unique with the collection, acts as the primary key of the collection. It is the key in the key or valuable pair. If you create a document without an underscore ID field, MongoDB acts the field for you, assigns it a unique based on object ID. Example for the MongoDB shell and the data modeling in MongoDB need to determine how to map entities and relationship collections of document. Could in the theory given each type of entity like it owns flexible formatted type of documented, those documents would be stored in the same collection. However, it can make sense to group different types of entities together. Create an aggregate containing data that trends to be accessed together. Capturing relationships in MongoDB is like two options, two references to other documents using the underscore ID values, embedded documents within other documents. These are the examples for the embedded relationships. And the queries in MongoDB are like each query can only access a single collection of documents use a method called DB collection find. And the example for the DB collection is mentioned below. Projection is like specifying the name of the field that you want in output with 1. 0 hides the value. And the example for the projection is the mentioned below. This selection, you can specify the condition of the corresponding attributes using the find. Operators for other types of comparison. For logical operators and or nor, use an array of conditions and apply the logical operator among the array conditions. Aggregation recalls the aggregate operates in SQL like average, sum, etc. More generally, aggregation involves computing a result from a collection of data. MongoDB supports several approaches to aggregation, single purpose aggregation methods, and aggregation pipeline MapReduce. These are the simple aggregations which returns the documents in the collection to satisfy the specific selection document. And it also returns an array with the distinct values of the specified field in documents that satisfy the specified selection document. In omit the query, get all distinct values of that field. Aggregation pipeline is very powerful approach to write queries in MongoDB is to use pipelines. And we execute the query in stages. Every stage gets as input some documents, applies filters or aggregations or projections and outputs somehow new documents. These documents are the input to the next stage and so on. Aggregation pipeline, here we use group underscore by to group document per state, compute some of the population and output documents with underscore ID. And the next stage finds a match of all states that have more than 10 million population and outputs the state and total population. And these are the continuation on the example for the aggregation. And the other structures we use in non-SQL like tables are unnatural, joins are able need to be able to grep my data. And the database has tables are in natural or neutral structure. Data independence lets you pre-compute joins under the covers. This is the price of all the DBMS goodness you get. This is an old debate. Object-oriented databases, XML DBMS, and hierarchical. And the float tolerance like DB scores are grain if trouble restrict transaction, few better nodes, some failures are rare. Transactions allow you to kill a job and easily to restart it. And NoSQL, massive amounts of cheap hardware and failures are the norm. And massive data means long running jobs. So must be able to do mini recoveries. This cause some overhead like file rewrites. So that's it. This is the thing mainly for non